Hi, I'm Daniel Jeffries. I'm the Chief Technical Evangelist for Pachyderm and also the Managing Director of the AI Infrastructure Alliance. And today I'm going to talk to you about when AI goes wrong and how to fix it fast. Now, with algorithms making more and more decisions in our lives, how do we know that we can trust those decisions? And over the coming decades, automated systems are going to make more and more of those decisions in our lives, some of them trivial and some of them very serious. It's one thing for an algorithm to mislabel a picture of your friends in Google Photos or to mistake a painting for a real person. It's another thing altogether when those intelligent systems are driving cars, hiring and firing people, promoting people, rating their workers, detecting health issues, handing out or denying loans, and or putting people in jail. Imagine that an app misses skin cancer because you didn't go to a doctor. Of course, the doctor might miss it as well, but would the algorithm or the maker of the app be at fault, even if the person should have gotten the second opinion? And how do we really know that these decisions are good? And we have to establish a baseline of trust because the stakes are just too high. And right now, we're not necessarily ready to deal with this as a society or as a business. Too many of the stories out there on artificial intelligence are sensationalist, or they're worried about things that are not real problems, and people are missing the incredibly important and difficult decisions that we're going to face as algorithms move into more and more aspects of our lives. So here's some examples of nightmare examples, really, of AI gone wrong. So Microsoft Hey was a chatbot that was exposed to the internet so that people could continue to train it. And of course, pranksters and people on the web immediately went to town, and some very unscrupulous people as well. And in no time, Microsoft Hey was shouting, Nazi propaganda and all kinds of other horrible, racial slurs. And there's the example of Uber's self-driving car. It hits and killed a woman in Arizona, and there was a number of different systems that weren't working well together. For instance, the car was using a long LSTM, but it wasn't really tied properly to the vision system, so that when the visual system couldn't detect the woman correctly, it didn't detect her as a person. It detected her as an unknown object, and then as a bike, and then as a person. It was flip-flopping between those. Every time it would reset the LSTM, which was tracking that object in space and how fast it was moving. And so it would start from scratch. And by the time it realized there was an object that was dangerous in front of it, was too late. And we've also seen all kinds of examples of people fooling facial recognition systems or visual recognition systems with things like putting stickers on or graffiti on stop signs in order to fool them. But these are really just the big problems. These are the flashy ones. They make the news when there's a car crash, et cetera. But there are much subtler problems in artificial intelligence. The PR disaster, really just the tip of the iceberg. And there are all kinds of hidden ones that we don't really pay a lot of attention to. When people, for instance, are getting resumes screened, are the algorithms doing a good job? There was an example of an algorithm developed in a proprietary way as a black box that was rating teachers, and a teacher who basically changed nothing from one year to the next had an incredibly high score and then an incredibly low score. There were teachers that were fired. And when they finally got access to these algorithms and through lawsuits and pulled them open and they plotted them, you would expect kind of a bell curve, and instead it essentially looked like white noise with data points all over the screen. There was really no methodology to it whatsoever. There's another example of something like the Compass recidivism scores in Florida that help judges decide whether someone goes to jail. A judge that may not be schooled in machine learning or artificial intelligence may just assume that the machine knows what it's talking about, and that it's infallible. And this is often the case that we see these things kind of happening where the machine is considered totally infallible, even if its algorithm has not passed any kind of audit or isn't open to the public, right? And is making decisions that are basically a black box. We could also see loan decision algorithms that leave out women who could pay back those loans. And so there's actually a real downside to these things, not just from a PR standpoint, but there's also an economic incentive to get these things correct. In other words, I believe that the ethics of artificial intelligence is often defined too narrowly, and that really when your algorithms are more and more correct, they have a better chance of making money, for instance, or of potentially doing the right thing. Again, sometimes these things are in contrast to another. If you just train an algorithm to generate the most time on a site, then it's going to be optimized to do that. But a loan algorithm, for instance, that's discriminating against women or leaving them out who could pay those loans back is leaving a bunch of money on the table. So there's economic incentive to really build these things into the system as well. So how do we fix the problem? So explainable AI could be one of the things that we use to get there. In the AI Infrastructure Alliance, we have Selden, for instance, one of the companies that Pachyderm works with closely, and they have an explainable AI framework that can peel back some of the decisions. So, for instance, if you have an image recognition system, it can highlight the various pixels that the algorithm thought was the most likely to reach its decision that was a cat or a person or a car or a truck or a bike. And so then a human can audit that later on, and that makes for the explainable artificial intelligence. But explainable AI is still very much cutting edge research. We've made some incredible strides with it in a number of different areas, particularly around structured data, where we see which bits or which features of that structured data are the most likely to cause the algorithm to make a decision. But in some areas, it's still very much cutting edge research, and we're still not fully there yet. And we also have to establish what explainability even really means at times, right? Sometimes we tend to think of it as just a human telling us what they mean, but in fact, a machine may only be able to show us kind of hints of what it means, and it still requires a human to go and look at it. So explainable AI is an incredibly important factor. We're going to see more and more companies coming to the fore and building explainability as the lawyers get involved, politicians get involved, governments get involved, and the general public gets involved. And we're going to start to see more and more rules where you have to explain and audit artificial intelligence over time. This will be a good thing. We're going to need tools to help do this, but explainable AI is still in very much cutting edge research. So how do most organizations try to fix this? Well, what they first do is basically form an AI ethics committee. And so essentially this group of people are generally not engineers. They're generally people in the business group or human resources or whatever. They may have limited understanding of artificial intelligence. The group inevitably meets, puts out a report on how AI should be inclusive and fair. It inevitably includes those words. And that sounds great, but it's ultimately not implementable because those are just abstract concepts and platitudes. They're not actionable steps. And so really nothing gets done. In other words, if you think about fair, it has a lot of different meanings to lots of different people. Inclusive has lots of different meanings to lots of different people. That's not something that's easily translatable to an algorithm. And so these reports tend to go nowhere. And we really need something that's a little bit more concrete and actionable if we want to start to weave ethics and an understanding of our algorithms into our entire process of creating and training these machines. So the middle path is that we don't need the explainability and ethics community to get us there. What we really need are two crucial teams. And I call this building an AI red team. Now, an AI red team has started to come on as a terminology. I've been using it for a number of years slightly differently. So I'm going to say that essentially a red team is two basic teams. One is a customer public facing team, and another is an AI red team, aka a QA or security for artificial intelligence. Let's talk about what each of those mean. The customer public facing team is one that is trained to respond to upset customers, the general public, internal customers, external customers, if you're business to business, or just talking to your employees, but also to the general public. They're taught how to understand the algorithms and how to make decisions, how these algorithms make decisions versus humans. They have ready-made templates to talk to the press with clear, concise language. Okay, so let's take an example of something like Google Photos, which had the horrible PR disaster of labeling people of color as gorillas several years back. Now imagine the pain of waking up to this, right? This is something that's incredibly painful for the person who experienced this and had to deal with it, waking up in the morning, seeing their photos labeled in this horrific way. But unfortunately, Google had to cobble together a response on the fly to try to come up to it. Somebody messaged them on Twitter, an engineer saw it, and they had to come up with a solution kind of on the fly. That's not going to work in the long term. That's not sustainable. You're going to need teams that are dedicated to understanding these things. So in other words, explaining it to the public. This is, people are going to have all kinds of questions who may or may not be familiar with the technology. They don't know that a rogue coder didn't do this to hurt somebody deliberately, or that it's not a policy of the company, that it was a mistake in inference by the algorithm. And they need people ready to explain how AIs work, say, hey, we're on top of this. We're fixing it very quickly. Here's the timeline, and we're going to keep getting back to you about it. And we apologize. And here's like, recompense, or here's how we deal with these types of things. So you're going to need a customer team very much trained, as there are more and more algorithms making decisions, both for your employees, whether that's hiring and firing, promotions, resume screening, whether it's public facing algorithms like picture labeling, facial recognition, loans, all of these kinds of things. You're going to need a team that's able to deal with things and able to kind of deal with problems as they arise and have good answers. And they're going to be able to push it down to the technical team, which is what I call the AI red team. Now, by the way, this is actionable intelligence. This is something that you can do right now with existing public relations people and a cross-functional unit of both engineers, human resources, public relations people, front-facing folks. Put them together, build a training program, teach them how these systems work, teach them how to respond to these things, set the program in motion now before it destroys your reputation or your bottom line. But it's not enough to just have public relations. You need to have a team in place that can fix these problems, okay, in a technical way. Now, an AI red team, in the way that I formulate it, is a group of traditional coders, data engineers, data scientists, MLOps engineers, QA testers. They're responsible for coming up with the triage solutions and long-term solutions. Now, what's a triage solution? A triage solution is when you come into the hospital, you meet the triage nurse. The nurse is trying to sort the most dangerous problems that need immediate attention, and the problems that can wait a little longer. So something like a stab wound, or someone bleeding profusely would be triage to the front of the line. Other problems that take a little bit longer, can be waiting, and so that prioritizes the resources. And so a triage solution is a short-term fix to the problem. Now, the way that Google fixed the problem with Google Photos was to just keep the deep learning system from labeling anything as gorillas or other types of animals. Now, they got a lot of pushback in the media for this, but in actuality, it is actually an effective triage solution. In other words, a triage solution is something that you have to fix right now. You need to stop the bleeding. You need to save the patient. You need to save your reputation. You need to save the bottom line. So a triage solution is by its nature a quick solution. However, they justly got criticism because you have to have a long-term solution to this, okay? And what does the long-term solutions look like, right? Well, for instance, a team might have to build a synthetic data set, or they might have to go out and expand their data set, augment their data set, right? This becomes kind of a cross-functional team where it's going to have to work with lawyers and business. So for instance, you might have to go and buy a commercial data set to expand the things that you're working on, and you may need to test that in-house before you commit to paying for it. And so there needs to be sort of legal agreements in place. You may need to use synthetic data, maybe a GAN. There's all kinds of things that you can potentially do to correct these problems, but the team has to first triage the problem and then implement quickly a long-term solution that allows them, that may take some time, right? But that allows them to address the problem over the long term in a very effective way. And to do that, you're going to have these teams built from the beginning. It's not going to be a team that you can just cobble together on the fly. You're not going to be able to just take your current core of data scientists and just throw this problem at them and tell them to fix it. You're not going to be able to tell your data engineers, just go grab new data and fix this. There's going to have to be programs in place in order to acquire that data, whether it's synthetic data or sending people out in the field to take more photographs or acquiring more satellite images, whatever it takes to do that. The refinement of algorithms, logging, explainability, all these kinds of things are going to be necessary, and you're going to have teams that are needed to be trained to do this from the very beginning, not cobbled together on the fly. Now, what kinds of things can we begin to use to help augment the AI red team? So there's a number of different things that we can take from traditional IT. Now, traditional IT, traditional DevOps are not a one-to-one ratio with MLOps, but there is some crossover. There's things that exist in machine learning, okay, that do not cross over, but such as training, right? That's a sort of a step that doesn't exist in traditional coding, and things like inference or model serving. These things don't necessarily have crossovers. Explainability doesn't necessarily have a crossover. Logging is even different in some ways, right? In a traditional logging system, you only need to worry about the current moment, and you can generally forget about history. You only need to know whether the web server is up or down. But and the only time you need to know the history is that server's been bouncing, but traditionally you can throw that out. Whereas with a monitoring system in artificial intelligence, you really need to have all of the inference decisions over time taken into account to see whether there's drift or anomalies that are happening over the course of that time. So your monitoring systems are different. But we do have a lot of analogies. So in other words, version control, data versioning, data lineage, which is something that Pachyderm specializes in, it's not something that can be bolted on. When you look at traditional hand-coded logic, the data is secondary. I am the programmer. I write all the logic for a login system. I make all of the decisions in there. I only touch the data as a secondary thing. Do your username and password once in order to verify, and then I log in. In a machine learning scenario, the machine learns all of the features and its understanding of the world from that data. And so this whole data curation step, choosing the data set, labeling, setting bounding boxes on there, you need strong, robust data versioning and data lineage. These can't be bolt-ons. For instance, in the Pachyderm file system, you have a copy on write file system that's taking constant snapshots over time so that you always have the different versions. And then you have a Git-like system that's doing lineage tracking, but it's different from Git. In other words, Git is not actually adapted for doing data, even with the plugins. In other words, data is in traditional code in Git is replicated down to the desktop. That's not going to work with petabytes of data. You're not going to have a petabyte of satellite, high resolution satellite imagery or video downloaded to each individual laptop. So you need to have a centralized data. You can use Git as an example, but not as the final system. So you need a system like Git that's tracking commits, that's tracking all the changes to the code, the models, and the data as it's changing. And it needs to be long-lived. So there are examples of for instance, Spark in Databricks and its Lakehouse looks at lineage as a very short-term thing. In other words, 7 days of lineage. In other words, it's only looking at it from the experimentation level during the experimentation as you build the algorithm. But these systems are actually going to need to be very, very long-lived. In other words, years or perhaps even longer. If government, for instance, starts to pass rules, which they inevitably will, we're already starting to see these in the EU and other places in the world where, for instance, you have something like a right to be forgotten, and someone may wish to be pulled out of a facial recognition database on an algorithm that was trained 2 or 3 years ago. You'll have to be able to go back using data governance tools to pull that person out of the database, retrain the model without that data, right? To exclude them from it. And if you don't have the correct data set, you don't have the lineage tracking it, you're in big trouble. This comes into the snapshots and rollback capability. In other words, it's not enough to just log it to a database. So we see a lot of these things in machine learning now, or a metadata server, which is essentially just a database. But that database, if it's not tracked with snapshotting and rollback and immutability, it can result in stale or incorrect metadata. In other words, If I record that I went to a specific URL for data, but that data is overwritten in some way, somebody came in later, changed all of the images. You had a million images in there that were 1024 by 768. They crunched them down to 512 by 512. Or you had a number of videos in there that were using one codec and were overwritten, or some of the videos were deleted or changed over time or modified in some way, et cetera. There's thousands and thousands of ways that data can change. Then that metadata store is not enough. You see all of these things in these MLOps diagrams of metadata store, but it really doesn't work to just have a metadata store if you're going to have stale data within there. So you really need to be able to track the lineage throughout the entire bit. You're also really going to need to have a strong CI/CD for AI/ML pipeline, and that's going to start to integrate things like unit and integration tests. These are still incredibly rare in artificial intelligence, whereas they're absolutely standard in traditional coding and traditional hand-coded logic, where you have thousands or tens of thousands of tests that run every time new code is merged. Eventually, you're going to need lots and lots of integration tests for the artificial intelligence. In other words, particularly for things like edge cases. And you're already seeing this in some of the most advanced groups that are out there, companies building self-driving cars. You might find there was an example of Lyft, where they were using virtual training systems. And there are some parts of the world where the left-hand turn signal, or the right-hand turn signal was something like that, was yellow instead of green. So like 0.1 or 2% of the time. And so the algorithm wasn't trained for it. So they had to bring in artists to paint that yellow left-hand signal to train that edge case. In the future, you're going to need to have edge case detection, where you can then go back and test when you've trained a new version of the algorithm, shadowed the old one, sunsetted the old version, and served it. Is it still making those kinds of decisions? You're also going to be, we're starting to see the emergence of really dev staging and production, but in a new way. So for instance, I might do a blue-green rollout in artificial intelligence, and in traditional coding, where I basically have a web app. I roll out new versions of the code. The new versions only need to last for a half a day or a couple of days before I know there's a bunch of errors that are happening or not happening, and then I can quickly replace all the old ones. What we're starting to see at the most advanced teams is when you roll out a shadow version, that algorithm has to exist for a long period of time in shadow, and decisions need to be sent to both the current version of the model and the shadow version for an extended period of time, and that auditing and logging needs to happen to make sure that the inference is on an equal level, that it's not making mistakes before that shadow version replaces the primary version in production. And so there's a delta in terms of time. So in other words, we can adopt a lot of the IT and coding practices from traditional coding, but they have to be modified for artificial intelligence, and in some ways they have to be done in a totally new way, or we need completely different systems to deal with those things. Even, for instance, again, we get to that auditing and logging, as I noted before, where it needs to be more long-lived, tracking those inference decisions over time. So again, version control, data versioning and lineage, especially of data. Git is still great for code, but not great for data. So you're going to need a different solution. Snapshotting and rollback, being able to trace things back to a certain period of time. A CI/CD for AI/ML, unit testing, dev stage production with shadow, blue-green deployments, and a new kind of auditing. You're also even going to need new processes for how you deal with the data. So Andrew Ng always talks about this in data-centric AI, where sometimes you look at data scientists will throw a bunch of different algorithms at a solution and only get maybe a 0.2% difference in terms of reliability or accuracy. But they realized that they had done a bunch of labeling on the data, and a bunch of the bounding boxes, they gave the human labelers a heuristic to do it, but that humans interpret it in a bunch of different ways. If you have 30 or 40 different people doing the labeling, a few of them might interpret it in a different way, put the bounding boxes in an incorrect spot, and therefore there's a degradation in the accuracy of the artificial intelligence. So you'd have to go back, find the 30% or so where there was a deviation, refine your heuristic, and then go ahead and have them relabel those things. And what Andrew had discovered was that sometimes you get a 20 or plus percent boost, 20 plus percent boost, because you've just gotten the data labeled more effectively. So there's a number of different things that we're going to be able to do to retrain these things over time. That's not even including things like synthetic data or GANs or augmenting the data set. But all of these processes are going to have to work hand in hand, synergistically, in order to deal with the anomalous effects of putting artificial intelligence in production. So you're also going to need, again, very sort of creative problem solving, and that's going to be one of the most important things. This is not going to be a team, by the way, that's just going to be able to have a rote solution to everything that you throw at it. They're going to have to analyze almost some of these problems over time, for instance, will start to become more templated. But there's no O'Reilly book for solving logistical problems, just as there's no sort of in artificial intelligence, right? Whereas we know many of, for instance, the security problems in traditional networks. We know kinds of race conditions or clickjacking or buffer overflows. These are kind of well-known attacks that we can look for over time, start to build on. In artificial intelligence, these are still emerging. So in the short term, your teams are going to have to be very creative. They're going to have to be critical thinkers. They're going to have to solve many different problems in a unique way, and then record and templatize those solutions over time. Keep up to date on the field as the field expands and becomes more mature. And there are more templated systems. There's going to be naturally AI security solutions that start to come into the fore, just as we have sort of antivirus solutions or monitoring solutions for routing and web that looking for attacks. We're going to begin to have these things in artificial intelligence, but in the short term, those things do not exist, and we're going to need a very creative team that is able to look at each problem, develop a triage solution, and develop a long-term solution for it over time, and then implement that solution and prove both to the company, the customers, and potentially to legal auditors in the not too distant future that they have selectively fixed the problem. The other thing is they're really going to have to come up with integrated tests. And again, many of this concept of a unit test or an integration test, regression testing is still very new in the field, and it's going to be emerging over the next 5 to 15 years. Over time, we're able to more intelligently audit and test the logic of our inference systems over time. Maybe we begin to develop a series of questions for the artificial intelligence that are always being looped at it when there's a new version put into production. If there was a series of resumes, for instance, you could have a corpus of kind of hand-picked resumes with a wide variety where you'd kind of independently scored these both by humans and by artificial intelligence over time that you're always going to feed to it. And you develop that in an automated way every time a new version of the software rolls out, every time a new inference engine rolls out, you test it against these kind of this hand-picked corpus of resumes over time to make sure it's still giving you accurate results. And if not, you're going to need to come up with an answer why. So these testing is going to become incredibly important over time in artificial intelligence, not something that anyone's going to be able to pick. First of all, the last thing to understand is that this is a universal problem. Every organization on Earth is going to face this in the coming decade. There's really no industry person or organization is going to be untouched by the power of algorithmic decision making, because artificial intelligence is a universal technology. It's going to be applicable in finance, healthcare, robotics, social media, internet companies, farming, agriculture, you name it. There is an application for artificial intelligence. And as it becomes integrated and woven into more aspects of our lives, we're going to need better ways to audit and control the decisions that we make. And again, research in explainable AI is going to continue to accelerate. And as it does, we're going to integrate those tools into our pipelines. But we don't have to wait until tomorrow. We can design better monitoring and management processes today with the tools and best practices that we've already honed over decades of IT development. And we can do the one thing that humans still very much do better than artificial intelligence, that use abstraction, broad critical thinking, and our ability to draw inferences between multiple domains in order to solve problems. Creative problem solving is really what is needed for us to begin to audit, train, understand these things over time. But we can rely on the best practices of the past to help us along as a template. Thank you much for your time. It's most appreciated. And I enjoyed talking to you today.